The Codex Principals. The work called Codex Universalis Principia Mathematica, associated with Robert Edward Grant, presents a philosophical mathematical framework that attempts to interpret the universe through harmonics, resonance, and recursive patterns in mathematics and physics. Rather than treating it as established scientific consensus, it is helpful to view it as a conceptual model, a way of interpreting relationships among numbers, geometry, consciousness, and physical forces. We'll outline the core principles in a distilled form without reproducing the source material directly. 1. The harmonic universe principle. The Codex proposes that reality behaves like a system of standing waves. In this view, structures in nature arise from resonance patterns, similar to musical harmonics. Mathematical constants, particles, and cosmic structures are interpreted as stable nodes in a universal wave field. Order in nature emerges not from randomness, but from harmonic stability conditions. The central metaphor is that the universe behaves more like a vibrating instrument than a machine. 2. Mathematical structures as resonant patterns. A major theme is that numbers encode resonance structures. For example, the framework suggests prime numbers may represent stable nodes in a numerical resonance field. Recurring decimal patterns in modular arithmetic may reveal hidden symmetries in number space. Mathematical constants could represent standing wave ratios rather than arbitrary values. Whether these claims hold mathematically is debated, but the guiding intuition is that arithmetic may reflect deeper geometric or wave relationships. 3. A universal harmonic scaling. Another key idea is that nature may follow recursive scaling patterns. The Codex emphasizes certain numerical ratios appearing repeatedly across scales, a specific irrational value used as a scaling reference. The suggestion that phenomena from subatomic to cosmic scales may follow self-similar harmonic ladders. Conceptually, it resembles ideas from fractal geometry or scale invariance, where patterns repeat at different magnitudes. 4. A unified field interpretation of forces. The Codex proposes that the forces of physics may not be fundamentally separate. Instead, it suggests gravity, electromagnetism, nuclear forces could all be different expressions of a single underlying field dynamic. In the model, expansion and contraction of fields correspond to different interactions. Physical forces emerge as different modes of oscillation within a universal field. This idea echoes historical attempts at unified field theories, though the Codex frames it in harmonic language. 5. The observer and consciousness. Philosophical component of the framework is that consciousness interacts with physical reality. The idea proposed is observation corresponds to phase alignment with potential states. Reality becomes defined through coherent interaction between observer and field. This echoes interpretations of quantum mechanics that emphasize the measurement problem, though the Codex extends the idea into metaphysical territory. 6. Geometry as the language of reality. Another principle is that geometry underlies physical law. In this view, waves generate geometric structures. Geometry organizes energy into stable forms. Physical constants and particle structures emerge from geometric resonance constraints. This concept aligns loosely with traditions in physics that see geometry as fundamental, for example, general relativity. 7. Reality as recursive self-reference. The philosophical conclusion of the Codex is that the universe may be self-referential, meaning the observer is not separate from the system. Consciousness, mathematics, and physical reality form a recursive loop. Awareness becomes one expression of the same underlying structure that produces matter and energy. A grounded perspective. Experimentally validated, they function more as philosophical or exploratory frameworks than established physical theory. However, they draw inspiration from real areas of inquiry: harmonic analysis in mathematics, wave physics, quantum measurement problems, fractal and scale invariant systems. So the Codex can be read as a symbolic synthesis of mathematics, physics, and metaphysical interpretation. A reflective note. Conceptual systems like this often serve as maps for thinking, not final descriptions of reality. What resonates for one person may function as metaphor for another. Examining the framework carefully reveals several major scientific criticisms raised by mathematicians and physicists. When ideas like those in Codex Universalis Principia Mathematica are evaluated through standard scientific methodology, we'll outline them clearly and calmly so you can see where the tensions arise between the Codex model and established science. These critiques address the ideas, not the intent of the author. 1. Lack of empirical testing. The first and most significant criticism is that the framework does not currently produce experimentally verified predictions. In science, a theory must 1. Make quantifiable predictions. 2. Be testable by experiment. 3. Produce results that others can reproduce. Many of the Codex claims are expressed as symbolic or harmonic interpretations, rather than precise, measurable predictions. For example, redefining mathematical constants, proposing new meanings for physical forces, interpreting consciousness as a field. These ideas would need clear experiments that confirm them before they could be considered scientific theory. 2. Redefinition of established mathematics. One of the strongest objections concerns the reinterpretation of the imaginary unit. In standard mathematics, this definition is not arbitrary. It arises from the structure of complex numbers which are deeply validated across electrical engineering, signal processing, quantum mechanics, fluid dynamics, relativity. The Codex proposes redefining I as a real number derived from a different constant. Criticism: if a theory claims to derive them, it must show. This breaks the algebraic structure of complex numbers. Many theorems in complex analysis would no longer hold. Equations that rely on rotational symmetry in the complex plane would fail. Because complex numbers are experimentally validated across thousands of technologies, redefining them requires extremely strong evidence. 3. Conflicts with quantum mechanics. The framework proposes rewriting the Schrödinger equation by replacing I. In standard quantum mechanics, the imaginary unit is essential because it produces oscillatory wave behavior. Replaced with a real number, wave solutions become exponential decay instead of oscillation. Interference patterns disappear. Quantum mechanics predictions fail. Since quantum mechanics has been verified to extraordinary precision, for example in atomic clocks and semiconductor physics, this modification would contradict experimental reality. 4. Misinterpretation of physical constants. Another criticism concerns the claim that constants arise from a specific harmonic number base. In physics, constants like speed of light c, Planck's constant h, gravitational constant g are measured quantities. Their values come from experiments, not from mathematical derivation. 1. Exact agreement with measured values. 2. Predictions for new measurable constants. The Codex proposals often approximate or reinterpret constants, but do not derive them rigorously from first principles. 5. Misuse of the fine structure constant. The fine structure constant alpha, approx 1/137, is one of physics' most precise numbers. Its meaning is well defined. It represents the strength of electromagnetic interaction. Critics argue that the Codex assigns symbolic or harmonic meaning to 137, connects it to unrelated scales, human size, cosmology, etc. But these relationships are numerological correlations, not derived physical laws. 6. Conflation of metaphor and physics. Another common criticism is that the framework blends mathematics, philosophy, metaphors about consciousness without clearly separating them. For example, describing the universe as music or resonance can be poetic, but physics requires precise mathematical definitions. When metaphor is presented as literal mechanism, it becomes difficult to test scientifically. 7. Use of Hermetic philosophy as scientific evidence. The framework links discoveries to the 7 Hermetic Principles. These ideas originate from philosophical texts like the Kybalion, not from scientific methodology. Science normally builds theories from observation, mathematics, experiment. Philosophical traditions may inspire ideas, but they cannot serve as empirical validation. 8. Scale matching without causal mechanism. The Codex often links patterns across subatomic scales, biological scales, cosmic scales. While nature sometimes shows scale invariance, fractals, turbulence, critics say the framework often identifies patterns without providing causal physical mechanisms explaining why those scales should be connected. 9. Lack of peer-reviewed publication. A key component of science is peer review. New theories are usually examined by independent experts before acceptance. At present, the Codex framework has not been widely published in major physics journals. The mathematical claims have not undergone extensive peer review. Without that process, ideas remain hypotheses rather than scientific consensus. 10. Numerical pattern finding bias. Human perception is extremely good at finding patterns in numbers. Critics warn that some Codex relationships may arise from pattern selection bias, searching for numbers that fit desired ratios, ignoring those that do not. This phenomenon appears frequently in numerology, which is why mathematics requires formal proofs rather than pattern observation alone. A balanced perspective. Despite the criticisms, frameworks like this can still have value as exploratory thinking tools. Many scientific breakthroughs began as unconventional ideas. However, the transition from concept to accepted theory requires 1. Rigorous mathematics, 2. Experimental validation, 3. Peer review. Until those steps occur, the Codex is best viewed as a philosophical mathematical proposal rather than established physics. The number 137 occupies a curious place in physics, not mystical in itself. Yet it appears in a constant so fundamental that some of the greatest physicists in history paused in wonder at it. The story begins with something called the fine structure constant. The fine structure constant, A. It describes how strongly light interacts with charged particles such as electrons. In simple terms, it tells us how electrons absorb or emit photons, the strength of electromagnetism, how atoms produce spectral lines. The constant combines several other constants where E electron charge, C speed of light, 8 bar Planck's constant, for epsilon 0 vacuum permittivity. Remarkably, A has no units. It is a pure number. That alone fascinated physicists. Why 137 fascinated physicists? Many constants depend on the units we choose, meters, seconds, etc. But dimensionless constants appear to describe something intrinsic about reality itself. So physicists wondered, why does nature choose this number? The inverse value happens to be very close to 137, which sparked curiosity. Famous reactions from physicists. Several renowned scientists openly admitted their fascination. Wolfgang Pauli, the Nobel-winning physicist, reportedly became obsessed with the number later in life. When Pauli died in a hospital room numbered 137, some physicists jokingly called it the universe's final wink. Richard Feynman, the famous physicist, once said, "It has been a mystery ever since it was discovered. All good theoretical physicists put this number up on their wall and worry about it." His meaning was simple: we can measure it extremely precisely, yet we still do not know why it has that value. Arthur Eddington. Eddington even tried to derive the number theoretically. His attempts did not succeed, but they illustrate how deeply it intrigued scientists. Where 137 appears physically. The fine structure constant controls many physical behaviors, atomic spectra. The splitting of spectral lines in atoms depends on A, quantum electrodynamics. In the theory of light and matter interactions, calculations are expressed as series expansions in powers of A. Because A, 1 over 137, the series converges nicely, which is why the theory works so well. Probability of photon interaction. Roughly speaking, A determines how likely photons interact with electrons. Modern measurements. Today, A is measured incredibly precisely. Alpha to the power of -1, 137.03599, -7. Points measuring A are used to test the accuracy of quantum electrodynamics, the most precise theory in physics. The deeper mystery. The real question physicists still ask is, Why does this dimensionless number have that specific value? Possible explanations might eventually come from a deeper unified theory, new symmetries in particle physics, unknown relationships between constants. At present, however, no theory derives it from first principles. It is measured but not yet explained. A grounded reflection. The appearance of intriguing numbers in physics can invite symbolic interpretation, but within science the task remains simple and patient, measure carefully, test ideas, and allow reality itself to answer. Mystery in this sense is not an invitation to certainty. It is an invitation to curiosity.